Okay, so we're now live. So would you like to tell us a little bit about who you are and your school?
Yeah, so to give a small introduction about myself, I'm Daksha Abhay. I'm 18 years of age. I'm one of the youngest qualified professional educators here in Sri Lanka. I work under the motto that what I gained in my personal career or the achievement that I have achieved should be passed on to the future generations. And all these students here with me are just only somewhat 3 to 4 years younger than me.
Hmm.
So I believe that I should give the maximum towards my greatest potentials to what I can give towards these students. And within this certain span of 13 years, we have achieved a numerous and unimaginable set of achievements. You can visit our website, wise.edu.lk, and witness of what we have achieved within this short span without anybody's help. So,
Wow.
so practically, if I start on, I have a list to state, but still, as we are running short of time, I would like to give this opportunity to my students. Sir, good morning, Dr. Jim Adams.
Good morning, everyone.
Okay, so Jim, would you like to introduce yourself? Maybe we'll get Jim to introduce himself, and then we can fire away with some questions.
Sure. So I'm Jim Adams. I have recently retired from a 27-year career at NASA, and before that, I spent 10 years working at the General Electric company building satellites. So over the course of my nearly 40-year career, I've been involved in over 30 spaceflight missions. Some of them have been to assist in the design of the International Space Station. I've sent missions to take 3D images of the sun, to measure the water that's being deposited around the globe. The probe that went to Pluto, the landers on Mars. So I've had really pretty much an amazing career. And Steve will tell you, there's usually not a question that stumps me, but I like the ones that stump me. So,
well, I know that Daksha students have prepared a whole bunch of questions for you. So what I would suggest is that if the students have got a question, yeah, no, that's fine. If the student who's got their question wants to come and stand up by the microphone, and then they can actually ask the question to Jim himself.
Sure. I give the opportunity to my lovely students now.
Absolutely.
Good morning, Professor Jim Adams.
Good morning.
What were your responsibilities as the NASA Deputy Chief Technologist? Is your job interesting?
So I had a couple of jobs that were probably the best job in the world, right? So yes, my job was always interesting. It doesn't matter if I was the Deputy Chief Technologist or the Deputy Director for Planetary Science. Those were the last two jobs I had, excuse me, before I retired. My duties as Deputy Chief Technologist was to advise the highest ranking manager within NASA. His name was Dr. Charlie Bolden, or General Charlie Bolden. And he's a 6-time astronaut. And we had the opportunity, my office and I, to make sure that he understood the technologies that NASA was going to need for the future, and whether or not we were investing properly in those technologies to assure that we could do the things that the United States was expecting the agency to do in the years to come. So that was,
Thank you, Professor.
You're quite welcome. So, Daksha, if they could also give their name, that would be really helpful. Though I can't.
Sure, Doctor. Sure.
I can't say that I'll remember them, but
But they're welcome to introduce themselves first.
Yeah.
Good morning, sir.
Good morning. And what is your name?
My name
Sorry?
is Chatuni.
Chat to me.
My
Chatuni,
name
okay.
is Chatuni. What is the basic objective of a satellite sent out to outer space?
So that's,
Good question.
Chat to me, that is probably the first time I've ever gotten that question. And so, so the basic reason that we send satellites into outer space has to do with the fact that man cannot go there easily anyway. So it's very difficult to send human beings into space. Today we have 6 people living in space on the International Space Station, but they're only 200 miles away, right? And the furthest that mankind has traveled into outer space is to the moon, which is quite a distance. It's like 256,000 miles, but we have sent space probes into the depths of space, all the way out to the edges of our solar system, because we can use robotics. And so these robotic spacecraft, they don't look like the robots you see in the movies. They look like satellites, but at every level, as they move out from in low Earth orbit to geostationary, where the TV satellites broadcast digital television, to Mars, to Jupiter and Pluto and beyond, those robots are our eyes and ears so that we can explore the amazing universe that we live in.
Thank you, sir.
You're quite welcome.
Good morning, Doctor. I'm Denver.
Good morning.
Is there any specific reason for the space station to be situated in the mesopause layer?
So in the mesopause layer. So it's a little low, isn't it? I mean, people might think of a deep space station as something that's pretty far out, like maybe up at geostationary or beyond. But I'll tell you, the main reason that the space station is located at the altitude that it is had to do with, that's my son, by the way. So has to do with how far the space shuttle could travel when we were building it. So the space shuttle was an amazing vehicle. It was like a space truck. We put cargo in the bay and we put people in the front, and then we would launch it, and it would open its doors and deploy all this stuff and carry supplies and equipment and building materials so we could build the International Space Station. But it could only travel so high. And so we put the International Space Station at the altitude that the space shuttle could reach.
Thank you, sir.
You're quite welcome.
Good morning, Professor. I'm Ishani.
Ashani, that's a pretty name.
Thank you, sir. Can you give us a clear definition whether Pluto can be considered a planet of the solar system?
I don't know, Shani, what do you think? Is Pluto a planet or is Pluto something else? I'll answer, but you tell me what you think first.
It is.
So you broke up. I didn't hear what you said.
It is a planet.
It is a planet. So when I was growing up, and this is a long answer, so I hope you guys don't fall asleep. But when I was growing up, there were 9 planets, and Pluto was one of them. And so there is a friend of mine. His name is Dr. Alan Stern, who is the principal investigator for the New Horizons probe that's been to Pluto. And he worked for nearly a decade of his life just to get to the launch of the Pluto probe, just to propose it, get the spacecraft built, get the team aligned, and then launch it. And then, of course, it traveled for 9 years to get to Pluto. In 2006, when we launched the New Horizons probe, at the same time, there was a worldwide group of scientists called the International Astronomical Union that decides these sorts of things. And they got together and they said, you know, we know so much about where Pluto is right now that we're not sure that it really is a planet. And so I'm going to pause there for a second and just say, if you were to go back to 1851, I think is the year, what or how many planets would you have had to memorize? The answer is 23. Why were there 23 planets back in the 1800s? Well, that's because the telescopes that we had back then were quite crude, and they were just beginning to develop better and better telescopes. And so what happened was, as we observed these 23 objects that we thought were planets, we realized that some of them were called asteroids. And so they took all the asteroids out, created a new group called asteroids, and that left us with 8 planets until Clyde Tombaugh came along in 1930 and found Pluto. So that's part of the scientific method, isn't it? What happens is we observe the universe around us, we categorize it or catalog it in ways that we already know until we realize we've got something different. And so that's what has happened to Pluto. Pluto was found in 1930. It looked like a planet. It had an orbit around the sun. And we said, this must be a planet. It's not an asteroid, so it must be a planet. And we left it as a planet. But along the way, we have done more and more observations of the region of space that Pluto is in, and we found over 1,000 different objects that are like Pluto out in that region of space. And so the International Astronomical Union said, wait a second, we might have a situation like they had back in 1851, where we found a new class of objects, and those objects are called Kuiper Belt objects. It's a ring of material around our solar system that is left over from the early stages of the formation of the solar system. And Pluto seems to be from among them. The really odd thing about Pluto is that it's a highly elliptical orbit. So it's not circular, and that's one of the reasons why the scientists said it's not a planet. It's in an elliptical orbit, and it cuts across the path of Neptune. So it's a rogue object. It's not really a planet. One of the other requirements to be a planet that they set was that it be spherical. Well, Pluto is spherical, right? And the third requirement is that it clear its path in front of it, like it collects the debris that's around it. And it appears that Pluto, combined with Charon, seemed to have enough gravity to be able to do that, but it still cuts across Neptune's path. And so the scientists felt, no, this isn't a planet. It's one of a new class of things called Kuiper Belt objects, or dwarf planets, if you want to call them that. And so right now, Pluto is not a planet. However, and I know this is long-winded. I told you it would be long. However, in our hearts, Pluto will always remain a planet. And so I wouldn't be surprised if there's a move among scientists in the next few years, especially after we got all that amazing data back from the New Horizons probe, to reclassify or re-reclassify Pluto as a planet. We'll see. So the answer is You're quite welcome. The answer is basically that science is always changing and adjusting itself for what it finds. And Pluto just got caught up in all of that.
Good morning, Professor. I am Zain.
Hi, Zed.
What is it like living as an astronaut at the International Space Station?
Oh, so okay. So to be clear, I'm not an astronaut. I've not ever been into space to visit the International Space Station, but I know very many that have. In fact, Dr. Katie Coleman used to work for me, and she spent 6 months on board the International Space Station and used to talk about it quite a bit. So there's lots of work to do on the International Space Station. We keep the astronauts very busy, but you can imagine floating around in space. It's hard to do your work, and so you have to have things like footholds and handholds so that you don't go careening off down the International Space Station. There's very little gravity there. Inside the International Space Station, we've got it set up so that you could work in clothes like you're wearing today. But outside, of course, they have to wear spacesuits if they go outside. Your food tends to be capsulated in plastic bags because you don't want debris floating around the International Space Station like cookie crumbs and that sort of thing. And but your body begins to change as a result of living in space for so long. And what happens is you're not using your muscles in the same way as you do on Earth. And so they begin to atrophy, which is a big word for saying they get weaker. And so as the muscles get weaker, then your body starts to change. Fluids move differently in your body, as well as your body starts to rob the bones of calcium. And so when the International Space Station astronauts arrive, part of their work every day is to spend 2 hours exercising so that their muscles stay strong, so that the fluids move properly in their body. And it also seems to have some effect on stopping the calcium reduction in the bones. So they go and they live, and sometimes they take things with them, like Katie took a flute with her, and other guys take toys or games. One astronaut took a Lego set up with him and assembled it on the International Space Station. So it's pretty much like living and working on Earth, except that Earth is down below you. So, Steve, would this be a good time to play that video that you had?
Sure, we can try. We won't play the whole video because it's quite long. I'm hoping that technology is going to behave itself. So let me click on play.
I should say that
let's see.
I've never seen it before, so I'm going to be guessing at what you're seeing.
Let's have a look to see if it works. Are you seeing the video now?
I am.
It's working.
So this is a view coming up on the cupola, which is the window in the International Space Station. And outside, you can see the circular solar array of one of the spacecraft that's visiting the ISS. I'm not sure which one it is. If we get a peek over the top, we might be able to get an idea. I believe that might be the, not exactly sure. You can see that the Soyuz module off to the left, that's how the astronauts arrive. Oh, okay, so this is the orbital ATK cargo ship that is docked with the International Space Station in the center window there. And
Excuse me, doctor, sorry for disturbing.
yes?
We have a small problem. We can't see the certain image clearly. It's not up. It's not in the big screen.
If you click on the small little window on the computer.
Yeah, we can see it now. Thank you.
Okay.
Steve.
Okay.
So did you want to back it up a little bit, Steve? Because that's a great view, cupola. And I'm going to step away for just 2 seconds. Give me a second.
Okay. So Daksha, are you able to see this?
Yeah.
Okay, good.
So as I was
Good.
saying, you can see coming up through the middle with the round solar array, one of the cargo ships that delivers supplies to the International Space Station. And, you know, they have to take everything they need to live in space up, including water. So there's a constant stream of visiting cargo ships. And then off to the left, actually, there are 2 Soyuz modules, which is how the astronauts arrive and depart the International Space Station. And so this is really kind of a neat view because you can see 3 visiting ships at the International Space Station. Those long stripy on the left-hand side, solar and thermal rejection panels. That's a solar array, though. So let's see, what else have we got? This is like a big picture window on the International Space Station. When I first joined NASA to help design the ISS, we put no windows in it. And astronauts said, absolutely not. We have to have a viewport. We have to have a way to see outside. And so that's how the cupola was born. So this is what it's like traveling through one of the modules. It looks like a science module.
They said it's the Unity module.
Unity. Oh, that was the very first American module. It was Unity and the Russian space station Mir that made it up to make the first International Space Station.
And it says there on the right wall are the mission patches left by visiting astronauts.
Well, there you go. That's right. I have a few of those patches myself. So, and then we're going to go through a tunnel. Steve, can you see what it says where we're entering? It's going to probably tell us in a minute here.
It'll probably tell us. What is interesting is that, of course, whoever's filming this is floating.
Yeah.
And just holding the camera and you know, picking up all the images without needing any special equipment, which is quite cool.
Now, this looks like a storage module of some sort, like supplies or trash or mail.
It says here, we have arrived at the Zarya functional cargo block.
Yeah.
So it's a cargo block.
Yeah, so this is where some of the visiting ships can mate to the International Space Station. And also where they store stuff. So, yeah, this is quite long.
It is. I'm just seeing if I can find anything, like if I fast forward it.
Like crew quarters or, you know, where they might be sleeping.
Let's see what I can find.
That's a science module, it looks like.
Oh, that's definitely a science module.
Yeah.
This is the workstation used to control the Canadarm2.
Yeah. So that's a way that we can have the robotics on the International Space Station controlled by the astronauts themselves.
And then we're going to fast forward.
You can see it.
How big is the International Space Station?
Well, from end to end, it's about the size of an American football field. But the pressurized volume isn't you know, that big. It's I wouldn't even guess how big the pressurized volume is, but it's probably like 6 or 7 school buses put together, or train cars. Maybe is probably a better analogy.
Okay, all right. Yeah. So we'll come back to maybe another video of the International Space Station, because I'm sure that there are lots more questions that the students would like to ask.
Thank you, Professor.
You're quite welcome.
Good morning, Professor. My name is Jehu.
Hi, Jehu.
What are the challenges faced when you are working at mission control in Johnson's Space Center.
Oh, so the challenges faced at Mission Control or any operations center is that you go from long periods of nothing happening to brief periods, very intense, very critical to the mission. And so you go from waiting to suddenly something's happening. So the spaceship is approaching, the astronaut has to reach out and grab it with the Canada arm and mate it. You have to make sure that the locks are locked properly so that the atmosphere in the station doesn't breach out into space. You're constantly monitoring the things that the astronauts are doing because we're taking data on the astronauts, and the astronauts are following procedures, and sometimes they phone home. But for the most part, oftentimes you're waiting for something critical to happen. Everybody that you see in those control desks at the International Space Station has a function. Some of them are responsible for communication. Some of them are responsible for thermal control. Others are responsible for keeping the computers up and running, and that sort of thing. And so everybody's focused on their little slice of the International Space Station.
Thank you, sir.
You're quite welcome.
Good morning, Professor. My name is Sanjani.
Is that Johnny?
Sanjani.
Oh, okay. I'll try again.
According to your knowledge, how many human life sustainable planets are there in the universe?
How many human life sustainable planets are there in the universe? Right now, we know of one. You know which one that is? Earth, that's right. We know about a number of Earth-like, or Earth's actually not even Earth-like, Earth-sized planets, but we don't know about the chemistries of those planets. Can you sustain life on Mars without putting the equivalent of the International Space Station on the surface? No, you can't. You can't go outside and play soccer on the surface of Mars. You know, so anywhere we go at the moment, if we take human beings with us, we have to take the technology necessary to keep them alive. So I don't really count that as a planet that could sustain life on sustain human life. So at the moment, we know of one. I think, however, that there's enough stars and enough planets around those stars that somewhere out there, there's got to be another one, but we don't know where it is just yet. That's a great question.
Thank you, Professor.
Good morning, Professor. My name is Sharon.
Hi, Sharon.
Has anyone come close to figuring out how to travel in the speed of light?
How to do what? The speed of light? Oh, how to
travel at the speed, yeah.
At the speed of light.
It has happened once, Jim. It has happened once.
Has it?
When there was a sale, I think, at the iPhone store, and they were opening up. I think that some people were moving at the speed of light, but I don't think it's been able to be done since then.
Yeah, that, or if there's pizza on the table, then my son makes a faster than light beeline. So no, not quite yet. Although that doesn't stop physicists from thinking about it and trying experiments and that sort of thing. So you know, at the moment, we think that the speed of light is sort of a boundary that we need to break. But years ago, people thought the speed of sound was a boundary that we had to break. So, you know, we'll see. I don't know if it'll be in my lifetime or in yours, but I certainly hope that someday we find a way to travel faster than the speed of light.
Thank you, sir.
You're quite welcome.
Good morning, Professor. My name is Alan, and my question is, how are astronauts trained here on Earth before they embark on space missions? How does emergency egress training help in this process?
Ah, okay. Ignore the telephone ringing in the background if you can hear it. Anyway, so how are astronauts trained here on Earth before they go into space, and how does emergency egress training help them? So the bottom line on emergency egress is that we have to have a way for the astronauts to get out in the event of an emergency. We're not 100% sure that the emergency egress that we give them is going to save them in an emergency, but at least it's an opportunity to try. And so for the space shuttle and for the Apollo launches, there was a zip line basically connected to the pad, the top of the tower. And if there was an emergency, the astronauts would hop in a basket and they would zip down this line, hopefully before they were injured, if there was some sort of catastrophic emergency. On the top of almost every human carrying rocket, except for the space shuttle, there's a tower. And that tower is really an escape rocket. So if for some reason it appears that the rocket is going to blow up from down below while they're in flight, then this escape rocket pulls the capsule containing the human beings away from that explosion. We know that the escape rocket works, but we've never actually had to use it with human beings in it. So so the astronauts are tested to know how to withstand the forces and the problems that associated with both of those kinds of emergency egress techniques, but we've never actually needed to use it. On the International Space Station, there's a procedure that says if there's a problem, then you go to a safe haven. And in that video earlier, you saw there were 2 Soyuz modules. Those are the safe havens. So astronauts, if there's a catastrophic problem on the International Space Station, the astronauts make their way to the Soyuz modules, hunker down in there, and if necessary, they can separate from the space station and come home. So that's the whole emergency egress strategy. How do astronauts train for living and working in space? There is a myriad of things that they do. Some of it's kind of fun. You get to scuba dive underwater and practice assembling things in what we call neutral buoyancy, which is as close to zero gravity that we can get on Earth for an extended period of time. They travel to meet their colleagues, and they work as teams on a variety of different things. They develop procedures for things that they're going to do, and they train and they train and they train for the things that will be their responsibilities. So if you're responsible for operating the robot arm, you will have thousands of hours of operating a robot arm on Earth before you go into space. So that's pretty much it.
Thank you, Professor.
You're quite welcome.
Good morning, Professor. I'm Kisal. My
Hello.
question is, space travel can put the human body through a lot of stress and pressure. What kind of medical testing does an astronaut have to go through to be physically and mentally prepared for duty?
Oh, so slowly but surely we're beginning to find out exactly what we need from an astronaut. You know, in the early 60s, when we picked our first 7 astronauts, these guys were test pilots. They were extremely physically fit. They were mentally highly focused individuals. Sometimes not the best team workers, but they were highly focused, because we were treating the early days of spaceflight as if it was a test flight program of a new airplane. Now we're beginning to understand that one of the best things for an astronaut to have is the ability to work in teams, the ability to cooperate with others, the ability to get their point across without having to be dictatorial. And so there's a lot of screening that the astronauts go through from that sort of social end of things. Still, you know, one of the first things that excludes people is education. Astronauts must be highly trained, and at least the ones that work for NASA, and skilled in a particular area. Usually it's some sort of engineering or science.
Thank you, sir.
You're quite welcome.
Thank you.
So obviously studying maths and science is very important
Oh,
amongst
yes.
all the students.
Yeah. Just got to get that little dig in there, huh?
Mm-hmm.
I hope you guys don't have too much homework tonight.
Good morning, Professor. I'm Brian.
Hi, Brian.
How does Spirit and Opportunity, the 2 Mars rovers, assist in the NASA's Mars Exploration rover project? What have they found? Is life sustainable there?
Okay. So Spirit and Opportunity were part of something called the Mars Exploration Rovers Project, MER. And Spirit, unfortunately, has it's ceased to function. And so it's not working anymore. But Opportunity continues to roll. Now these things, these robots, they were designed to last for 90 days. And they are now going on 10 years old, I think, from when they landed on Mars. So they keep on rolling. And as you know, there's a third rover that we should talk about called Mars Curiosity, and that's still roving on the surface of the planet as well. So Opportunity and Curiosity are still moving, and they each carry a different sort of science package. The Mars exploration rovers carried fundamental things like high-resolution cameras and a drill and a brush, the sort of thing that a geologist might carry. The Curiosity rover carries a chemistry lab, so you could scoop up soil and put it into this laboratory, or capture some atmosphere and put it into this laboratory, and it will tell you what the components, the chemical components are. And so we have gone from exploring this environment with Spirit and Opportunity to trying to understand it more deeply with Curiosity. And we're going to continue that in 2020 when we launch the next Curiosity class rover to go to Mars. They still haven't picked the destination yet. Oh, you're quite welcome, but I'm not quite done. So you asked also, is life sustainable? That's part of what the Curiosity program is all about. They're looking to see, are there signs of life on the surface of Mars? The answer so far is we don't think so. So although there's one big question that has yet to be answered, and that is the whole question of methane emission on Mars. There's methane that's coming and going on the surface of Mars. And you know, Mars has the methane comes from 2 sources. It either comes from geologic activity like lava flows and volcanoes, or it comes from life itself, either decaying life or excrement and that sort of thing. So we're trying to figure out where this methane is coming from. And so far, we don't know. We haven't seen any geologic activity, and we haven't seen any life on Mars. Perhaps you'll come work for NASA and help us figure it out.
Good morning, Professor. I'm Damien.
Hi, Damien.
Is it possible by 2030 to construct a human settlement on Mars, having all the basic requirements that they needed to live a normal lifestyle as we do on Earth?
So, depends upon your definition of normal, but I believe that yes, by the 2030s, probably 2035 or maybe a little later, planet Earth will have a permanent settlement on Mars, and there will be vehicles coming and going to that settlement, just like you saw vehicles that come and go to the International Space Station. Can they live a normal life? They will live a life that's very much like life on board the International Space Station, enclosed in pressurized volumes, climate controlled, but on the surface. And if they have to go out, they'll have to wear spacesuits. They will have rovers that they can travel in, vehicles that will enable them to cover larger distances than they could walk, and they'll be pressurized as well. But there won't be anybody, like I said earlier, playing soccer on Mars.
Thank you, Professor.
You're quite welcome. Or football. Is it football or soccer in Sri Lanka?
Football.
Football. Sorry.
Good morning, Professor. My name is Nigel. What are the biggest challenges faced when it comes to space exploration?
Oh, hands down, it's Earth's gravity. You know, getting away from Earth's gravity is the biggest problem in space exploration. It only takes us a few minutes, but you see those big rockets, only the tiniest bit at the top is what we're trying to get into space, and all the rest of the rocket is fuel because we're trying to get away from Earth's gravity. And so once we get out into space, there's a myriad of things we can do and places we can go and ways that we can get there. It's really quite an amazing place, space. In fact, I've not seen any two destinations in our solar system that are the same. So it's just a fascinating place. And as far as I'm concerned, the hardest part, the biggest challenge of space exploration is gravity.
Thank you, sir.
You're welcome. Are we out of questions? Oh, the video just froze up, that's all.
What was your toughest mission yet?
Oh, I think the toughest mission that I was involved in had to have been this mission that we launched in 2006 called Stereo. It was 2 robotic spacecraft. They don't orbit the Earth, they orbit the sun. And they go out and they each have the same set of telescopes on them. And so one can look at the sun from one angle and the other can look at the sun from a different angle, and they get the same kind of binocular separation like you get with your eyes. So we can actually have some depth perception on the material that's coming off the sun and tell us a lot about the solar wind and how that interacts with the Earth. But the reason that this particular mission was challenging was really twofold. One was we had to put both satellites on the same rocket. And so when it took off, we had to send this one that way and that one this way. and that turned out to be harder than most people thought, although it was successful. The other major challenge associated with stereo wasn't technological at all, but it was social. It was how to get the team and NASA to play together to focus on a single goal of getting the stereo mission to the launch site. When I joined, and my boss, we joined at the same time, the team was already in a bit of disarray. There was a lot of infighting. There were people that think, no, it should be this way, or no, it should be that way. And so they needed people to come in like myself and my boss to draw some lines and say, no, this is the way we're going, and your job is this and your job is that, so stop fighting and let's get on. And so a lot of the work had to do with teamwork.
Thank you, sir.
You're welcome.
Good morning, Professor. I'm Roche. Do
Hi.
you think it is possible to time warp in space with the correct technology?
So I missed that. Do I think it's possible to do what in space?
Time warp.
To time.
Time warp.
Oh, time warp. Time warp. So that falls into the same category as traveling faster than light. And you know, Albert Einstein said, you know, time is relative to speed, and things will change as you move faster and faster, get closer and closer to the speed of light. I think that it's possible, but we are nowhere near knowing how to do it. I think it's possible for particles in space, but would a human being survive such a journey? I'm not so sure at this time. So
Thank you.
that's a good question.
When deciding an astronaut suit, what points are taken into consideration?
Okay, so when deciding on the design of an astronaut's suit, what points are taken into consideration? Well, first off, will the design of the spacesuit, I presume you mean one that enables them to work outside the International Space Station in an unpressurized volume. One is will the suit keep the astronaut alive, right? So protect him or her from the vacuum of space, provide them with the right kind of oxygen, scrub out the carbon dioxide, provide the necessary communications. The astronauts, on the other hand, they love doing the extravehicular activity. We call that EVA. But for them, the most important feature of a spacesuit is the glove. Because without the glove, they can't do anything outside. And so the most vulnerable part of a spacesuit is the glove. It has the thinnest layers so that the astronauts can actually bend them with their fingers. And if you imagine, a spacesuit is at roughly the same pressure as on Earth. It's actually a little lower than that. And but outside in space, it's vacuum, and so everything is going to puff up like big balloons, right? And so will the fingers of their gloves, and so it's very hard to move the fingers of the gloves on a spacesuit. Oftentimes, you could find an astronaut, and if he was squeezing a tennis ball, or she was squeezing a tennis ball, that meant that they'd been assigned a mission and they were getting the muscles in their fingers ready for being able to use those gloves. So one, keeping the astronaut alive, scrubbing out the carbon dioxide, communications capability, and dexterity gloves are all extremely important.
Thank you, sir.
You're quite welcome.
Good morning, sir. I am Devudu.
Good morning.
What is a black hole, and what do you think in the worst case scenario if one of your teams ever got sucked into one?
What is so?
What is a black hole? And that is a tough question.
so here's what I think, but I'm not an expert. So a black hole is a dying star. The star dies and it starts to collapse, and the material just keeps pulling itself closer and closer together until it gets so very dense that the gravity around it gets really intense. And in fact, what we're finding now is that almost every galaxy, you know, like the Milky Way has those spinning arms, at the center of our galaxy is a black hole, a supermassive black hole. And that we're beginning to realize is what makes a galaxy stay like a galaxy instead of everything just sort of flying around. So black holes are a necessary part of our life. What would happen if we were to approach what the physicists call the event horizon, close to a black hole, where we're moving faster and faster and faster into it? Nobody's really sure. If you were to go beyond the event horizon and actually into the black hole itself, I am absolutely certain you'd be crushed into teeny tiny bits of matter, and you wouldn't survive, obviously, and there's no getting out. So you're quite welcome.
Good morning, Professor. My name is Aranya.
Good morning.
Believing that there are alien life forms who are much intelligent than we can possibly think of, will there be any risk involved of trying to make any connections with the unknown life forms by exposing our world to them?
So there's always a risk in exploration. There's always a risk. If you met me in Sri Lanka tomorrow, right? You'd be taking a risk just to walk up to me and shake my hand. You don't know how I'm going to respond. You don't know if I'm going to smile at you or if I'm going to run away. You have no idea, right? And so I think that we have to do the same thing if and when. By the way, if is huge because they're at this point in time. I believe there's no evidence of super intelligent aliens that are anywhere close to Earth. And in fact, the SETI project hasn't found any evidence anywhere in the galaxy. But if that was a possibility, I think that we would have to be brave. We would have to step forward and say, this is us, and we want to learn about you.
Thank you, sir.
You're quite welcome.
Well, Doc, that's the end of our questions.
Oh, sweet.
Wow. I must just say that those were an excellent set of questions.
Indeed.
Thank you, Mr. Steve.
And you kept him on his toes.
So,
and to finish off, even I have one question to ask from Dr. Jim. Can I ask from you?
Oh, sure.
So, as a youth here of Sri Lanka, I consider you as an inspiration. I have been following your work. And what is your piece of advice? What can you tell us on how to become a NASA engineer or an astronaut? Because there are some of my children who are someday dreaming of becoming such a certain great personality.
Awesome. So you as youth today have an opportunity that I didn't have when I was your age. Space is opening up to everyone. And you don't have to work for NASA or the European Space Agency to be involved in space exploration. In fact, the opportunities to explore space are getting bigger and better and more open every year. And so even today, there are high schools that are putting together their own satellites. They're called CubeSats, right? There are nations that you never would have thought of that have their own space agencies. Local to you, India has an amazing space program, right? And even now, there are companies starting up by private citizens, companies like SpaceX and Blue Origin, and the one in Europe that I can't remember the name of, that have been started by private citizens because the founders have their own visions. Like Elon Musk, he wants to put a colony on Mars. Well, you know, I support that. You know, I think what we're doing is we're making space available to everyone, right? So you don't necessarily have to come to the United States. That would be helpful, probably. But you could maybe even start a Sri Lankan space program. And I would suggest you start with astronomy and then move from there and consider Earth resources or Earth observation. And then beyond that, you know, you could get some education and perhaps apply for one of the astronaut corps. But I think that in the future, there'll be more and more people going into space. And for every person that goes into space, there's hundreds of thousands of people behind them working on Earth to make that a possibility. So from my perspective, space is an open game. What to study? People ask me that a lot. Math, for sure. Science, absolutely. Engineering will never let you down. So study your science and your math and your engineering. But as I've alluded to a couple of times, learn to function in groups. Learn how to get along and how to influence people without exerting power. I believe that that's going to be one of the critical roles as we set up a colony. I don't like the word colony. A settlement. Yeah, right. A settlement on Mars. And so, so even though your students may not like it, math, science, engineering are all outrageously important. If you try and get to work for NASA and you don't make it, that's okay. There are other options. There are companies that work for NASA that you can work for. There's always partnerships among scientists. There is the opportunity for you to create your own program, which is just getting brighter and brighter. So I think this is a fantastic age to be your age in.
Thank you, Dr. Jim, for great words of wisdom. I hope my students learn a lot from you. Thank you for your precious time.
Yes.
If there's just two things, can I just say two things quickly?
Yeah, and I got one.
First, okay, I first want to just say that we're thinking of you guys. We know that you've had some floods out in Sri Lanka, and it might have affected some of the students today. So just know that we are thinking about you. And we also hoping that Saturday's cricket game between South Africa and Sri Lanka is going to be played in good spirits, and may the best team prevail.
So your first thing was my thing too. Our thoughts and prayers go out to everybody in Sri Lanka with the flooding. So I could tell you long stories
I really
about.
appreciate that, Doctor.
Yeah.
And
Yeah.
thank you, Mr. Steve, for giving us this golden opportunity. I can't
You're
thank
absolutely
you.
wonderful. You're always welcome. And remember, now that I've got you on my mailing list, we do a lot of interviews with other fantastic people like Jim. We are hopefully going to be doing a live Google Hangout with the International Space Station sometime this year. And we'll make sure that we involve you in all our future interviews.
Thank you.
Thank you.
You're welcome. You're welcome.
And I might also compliment you on how well prepared everybody was. I was really quite amazed.
Give ourselves a good clap. Come on.
Yeah. So, all right. Have a great day, everyone.
So thank
Thank
you
you,
very
Dr.
much.
Jim.
Bye-bye, everyone. And I will
Bye.
email you the YouTube links and stuff like that.